So we'll have to write a program to display factorial of an integer given by user. The formula of n factorial is 1 into 2 into 3 up to n. So first of all, we need to take an input from the user. For that, we would first declare a variable in which we want to get the input from the user, and then we will prompt the user, say enter n, and by using scanf function we can get the input from the user and store it in variable n. So the second parameter of scanf function is address of n variable in which we would store the input from the user. Now after getting the value of n, we want to evaluate this multiplication series. So here if we see, this is a multiplication series in which a term is one more than its previous term. So 2 is 1 more than 1, 3 is 1 more than 2, like that. So a term is 1 more than its previous term. Now if we see the ith term of the series, like the third term of the series is 3, fourth term of the series is 4, so on and so forth. That means there is no extra logic here. The ith term, the value of I itself is the value of the ith term. Now for evaluating this terms of the series, we would write a loop, because here the terms are following a pattern. Every term is one more than its previous term, and whenever there is a pattern, there is a logic which is repeating, and repetitive logic is built using implemented using using any loop. So we would be using a for loop here. First of all, we would declare a loop variable I, and we would initialize the loop variable with 1. Let us say it's stopping it. So there are n terms in the series, starting from 1 to 2, then 3 up to n. So there are n terms in series, so we want this loop to run for n times. Now ith term of the series is the value of I itself. So at the first iteration, I is equals to 1, that is the first term of the series. In the second iteration, as the value of I gets incremented by 1, in the second iteration value of I is 2, which is second term of the series. The third iteration, value of I becomes 3, which is third term of the series. So we can see that the value of I itself gives us the ith term of the series. Now we'll have to keep on multiplying the ith term of the series into a certain variable, which after multiplying the numbers one by one up to n would contain the factorial of n. So that variable, let us declare that variable first. Let us call it as fact, and as we are starting with multiplication, and if you don't initialize it, it would contain a garbage value, so we'll have to initialize it with 1. So see, if when we are solving a summation series, we initialize the accumulation variable with 0, but when we are solving a multiplication series, we would always initialize the accumulation variable with 1, because if we initialize it with 0, any term we multiply in it would remain 0, right? So the value of fact would never burst from 0. So for multiplication series, the initialization value would always be 1. Now accumulating the multiplication of the terms one by one would need this statement: fact equals to fact into I. So this is what we need. Now let us see how the factorial of n would get accumulated in this variable after this loop has run for n times. I have done a little mistake over here. The stopping condition should be I less than equals to n. So now how the statement would get executed. In the first iteration, when the value of I is 1 and the fact's initial value is 1, so 1 into 1 is 1, that gets stored into fact. Now in the second iteration, when I becomes 2, so the value of I represents second term of the series, that is 2. Now the fact contains 1, 1 into 2 is 2, 2 gets stored in back in fact. The third iteration, I is 3, value of I is 3, that is third term of the series. Now the fact contains 2, 2 into 3, that is 6, 6 gets stored in fact. The fourth iteration, I becomes 4 and the value of fact is 6, 6 into 4 is 24, so 24 gets stored in fact. Likewise, this loop would run for n times, and at every iteration we would keep on accumulating the multiplication of ith term of the series into the fact variable till this stopping condition uh, is made false, becomes false. um, After which the control would come out of the loop and the fact would contain the value of n factorial, because the last term of the series would be n, right? So starting from 1 we are multiplying the numbers one by one up to n. As soon as I becomes n plus 1, the loop would um, the loop would stop, the iterations would stop, and the control would come to the next statement after the loop. So after the loop we can write printf factorial factorial of uh, percent d equals to percent d. So factorial of percent d equals to percent d. So first, in the first placeholder, in place of first placeholder, I want to get the value of n printed, and in the next, in place of next placeholder, I want to get the value of fact. So if the value of n is given as 4, then on the console we would be able to see factorial of percent d would be replaced by 4. So factorial of 4 equals to, and percent d would get replaced by the value of fact, which is 24. So factorial of 4 equals to 24. That is how the result would look like on the console. And as the last statement, we would write a getch, because we want to see the results on the console. Now let us run it and see if it is working correctly or not. So first of all we would build it, and then so the build is done. Now we would run it, enter value of n, let us enter 4. So factorial of 4 is indeed 24, so it is coming out to be correct. 1 into 3 into 1 into 2 into 3 into 4 is actually 24. Let us run it one more time. Now I would give a value of 5, and indeed it is 120. 4 factorial is 24, 24 into 5 is nothing but 120. So the results are coming out to be correct. That means our program is behaving correctly. So this is it. We would see more programs in our next sessions. Thank you.